So AI really is a bit of a nebulous term, and it's actually recently started to be slapped on a lot of different areas. So I'm going to give you sort of my view of it, but do know that people will use the terms in different ways. Uh, AI, part of the challenge is that the very meaning of AI has changed over time. Back in the 1950s, people thought of AI as being specific problems to solve specific types of programs to solve specific types of problems, like the general problem solver, perceptron, which modeled a single neuron, expert systems. And then we actually did in the 1980s, for a brief period, have neural nets. But then it wasn't really until 1990s and 2000s that we started to get into stuff that really began to impact business. And so this was machine learning and gradient boosting. These were machine learning algorithms that actually could solve real-world problems and deal with large amounts of data and give you insight that previously hadn't really worked all that well in business. And so these are still probably the most commonly used tools in data science and in predictive analytics. But really, since about 2010, deep learning solutions have started to really come to the forefront. These have a lot more capabilities than the machine learning approaches, in that in machine learning approaches, you can think of it along the lines of you having to spoon feed the algorithm. So any features that might be important, you have to explicitly pull out of the data and then train the algorithm on those engineered features. To give you an idea, if you wanted to build something that used images, for example, and let's say that you wanted to build something and you wanted to determine how many people were building masks, were wearing masks in a crowd, and you wanted to be able to just make a quick estimate of how many people might be wearing masks. If you were to try to do that with machine learning, random forest, gradient boosting, logistic regression, you would have to separately design a program that could identify masks. So that's something you'd have to create. You'd have to code that up yourself. In deep learning, the game entirely changes. In that, you actually train it on images, and it figures out what the features are that indicate whether someone is wearing a mask or not. So in machine learning, it may be, all right, if I have two things that I think are an eye and a nose, or two eyes, can I see a mouth? And if you can't see a mouth, then there's probably a mask there. In the deep learning approach, you actually show images of faces with and without masks in different orientations and different lighting conditions, and the machine learning algorithm